in the diagram below, you have two circles which are touching each other. Maybe what will make sense here is that let's try to highlight our circles. So we have circle number 1 and then we have circle number 2. And then the other thing that they say that they have a common line, which is a tangent. So if we check here, they're saying these two circles, they touch each other at P. So they touch each other here at P. Here's the point of contact between the two circles. And then they say QPR is a common tangent. So this is a tangent for both circles. It's a tangent for the blue circle and the red circle. So I will refer to them that way now. So I will say which we have the bigger circle and then we have the smaller circle. So we have blue and red circle. Okay. Now, once you have a tangent, it means the other thing that you can look for now is going to be your chord theorem. Come back to that one when we need it. I'm not going to use it now. I'm going to use it. I'm going to work on it when I need it. So we have the tangent. And then the other thing that they said EDRC, it's a tangent to this smaller circle. So if you look at this one here, or the blue circle, you can call it a small circle or the. So if you go here, we have another tangent. So because they're telling you which this thing here is a tangent, it means which you can also expect a chord theorem. But the chord theorem for this one is going to work only on the small circle, on the blue circle. It's not going to work on the bigger circle. Because according to the bigger circle, this thing here is not a tangent. Actually, it cuts the bigger circle. And then it says which the point of contact here is at C. Now, there are angles that we're going to be working with here. Given angles, that is very important. So let's go to our given angles. These are the angles that we're going to be using. So we have angle number 1. Angle number 1, which is given, they are saying which they are giving us this angle here, they say which it's Y. So this is angle number 1, it's Y. And then we're also going to have angle number 2, which is given. These are important because they are given. These are the angles that we are going to be working with. If you want to name any other angle that they need here, it's going to be in terms of these two angles here. So anything that you're going to get, these are the two people that you're supposed to use. Now, as soon as we're done with that, then we have parallel lines. Now, with parallel lines, you need to look for fun. You need to look for Z. Start on one point of the parallel line. I can also start on the other point of the parallel line. Here's what I cannot do. Yes. I can't start here on B because B is not parallel to DC. So that the parallel lines, we don't have parallel lines between A and DC. So I can't have alternating angles equal here. Are you still fine?
Yes.
Okay. So if we then move on with this thing here, it says, okay, these are alternating angles, these are alternating angles because I started from one point of the parallel line. And then I also started from one point of the other parallel line. And then I got alternating angles. So let's look for the F shape. Again, with your F shape, you still have to do exactly the same thing. You're going to start from one parallel line. So if you start from a parallel line, let's look at that. So I'm going to start here at B. I get a B is parallel to AD. Can you see that again? And then these two are parallel to each other, then I can form an F shape. If I form an F shape, it tells me which this whole thing here is going to be equivalent to this angle here. Then in other, it means which now I can safely say which, okay, this one here. This, I get this one is X, this one. And then this one here is Y. So it means with this angle here, I can say which is going to be X plus Y. And then the reason why I'm saying this is because I have corresponding angles. Yeah, because of the parallel lines. I still find them.
Yes.
Okay, let's move on to do the first question. The first question says we should name other angles that are going to be equivalent to X. So X is the main character. Now we're going to look for other people which are going to be equivalent to X. Now what do we have in our disposal? In our disposal, we have number 1. We have this red circle. We're going to concentrate on the red circle. This is how I want us to approach the question. Let's go on circle number 1. On circle number 1, we're going to look at X again. And we're going to look at who created X. That's where you usually start. Who created X? And then you try to check which are there any other people which are subtended by the same person who subtended X. That's how we go about this question. So let's check who's subtending X. Now you go from A again here. And then you end up where at D again. And then you go from A, and then where do you end up? P. So it means which this angle here, X is subtended by what? By DP. Okay, that's fine.
D.
We do have an angle. We know that X is subtended by DP. Okay, good for us. Now, if this is subtended by DP, then is there any other angle subtended by DP? That's what we should ask ourselves. Let's go and check. Let's go from P again, and then we extend this line.
Yes.
Wait,
E.
and then we go from D, and then where do we end? At E. Then it means which this angle here is subtended by what? By P.
X. By
So
D.
it means this is X, and then this is also going to be what? To be X. So that's how we start. So I'll say, okay, my number one. Okay, this is one, this is two. So I will say angle A1 is going to be equaling to angle E, which is equaling to X. And then our reason is going to be angles in same sec. We are fine again. So that's how I want us to start. I want us to start with the given angle. From the given angle, check who's subtending the given angle. Before we go to Abutani chord theorem, before we go to parallel lines, let's start with who's subtending the given angle, the one that we need to work with, and then check are there any other people which are subtended by the same thing. It's possible sometimes the person who's subtending the same person as this angle here is at the center. Then we know which way the angle at center is twice the angle at the circumference. Okay, now we are done with this one here. We're done with this one here. The next thing that we want to check then is this. We have parallel lines. Okay? Now, because we have parallel lines, it means which we can then speak of alternating angles. Okay? Now, as you saw here, we said to you, A1 is going to be equaling to C2, which is equaling to X. And then our reason here was because we have alt angles. And then the reason why these things were alternating is because we had AD, which is parallel to what? To BC.
B.
Yeah, BC. So as you can see here, you see when it comes to parallel lines, I decided to say, well, let's highlight the parallel lines. But I didn't want us to confuse ourselves to highlight parallel lines and also highlight the tangent. So I went with the parallel lines. Yeah, because the parallel lines, they are not there often. So I went with those. Okay. We need how many angles which are equal to X? We need 4 again. How many have we got now? We got 2 again. Okay. Now we got this one here, which is in a different circle, man. It's in the small circle. Again. Because this one is in a small circle, we need to redo whatever it is that we did this side. So we got this one is X again. We want to check who's creating this angle C2. Again, now we're on the blue circle. We're done with the red circle. Let's go to the blue circle. If we go with the blue circle, we want to check who's creating this angle C2. Yeah, let's go and check who's creating C2. So we go from C again, end up at what?
Yes.
And then if we, and then if we go from C here, we end up at what? At B. Okay. That's is there any other person which is subtended by this line PB on the blue line, on the blue circle, I mean? It's angle T, ne? But angle T here, it's not at the circumference, so that this one doesn't work. So we'll move on. So it means we don't have angles in the same segment again. Okay, now that we don't have angles in the same segment, then we want to move on. We want to check something also which is equivalent, which we have a tangent. So if this one is a tangent here, we want to check who's subtending angle X. Again, who's subtending angle X?
It's DP.
It's DP again. And then we're going to check we have an angle between a chord DP and a tangent. That's what we want to check. Do we have an angle between a tangent and chord DP? Do we have something like that? Yes. What is that angle? It's
Angle P1.
Yeah, then it means in other words, this angle is going to be equal to this angle. And then we'll say which A1 is going to be equaling to P1, which is equaling to X. And then our reason here is going to be tan chord theorem. Second, we want to check exactly the same thing. Nothing has changed. We're going to check exactly the same thing. So on the blue circle, what we want to check who's creating this angle that we have. It's a given angle now. Do we have it? So the angle that we have, it's X again. Who's subtending X?
It's BP.
It's BP. Okay. Do we have an angle between a tangent and chord BP? That's what we should ask ourselves.
Yes.
Yes.
What is that angle then?
P6.
P5. P5.
If P5, no? Yeah, so
Yes.
it's going to be P5. And then, so we have P5 here. If we have P5, we come and say, okay, let's put it this one here, it's also going to be equaling to X. And then we will say we have C2, which is equaling to P5, and then which is equaling to X. And then when they ask us why are we saying that, we'll say which we have tan, chord, theorem. Next one. So on the next one, we want to have X and Y again. We want to have X and what and Y. And then we say we should show that EPA. So I'm going to just highlight the angle that they're talking about. They're talking about EPA. So let's go and check what is EPA. So we have E. This is E again. This is P again.
Yes.
Then this is A.
Yes.
So I'm going to highlight. I want to use it. And then we are not just looking for P7. They are saying which we should show that which P7 is equal to X plus Y again. Okay, we're going to start with X plus Y. Again, now they give us a direction to say this is how we should work. We're going to start with what? With X plus Y. So what do we know as X plus Y? This is the first person who's equaling to X plus Y. C1 plus C2. Now C1 plus C2 is equal to X plus Y. Now, who else is equaling to C plus Y? We already know that, yeah, X plus Y again. We already know who's equaling to X plus Y. We already have an idea. Who else is equaling to X plus Y? It's D1.
D1.
Yeah. So we'll say, okay, C1 plus C2 is equaling to D1. Now they need to tell us why are we saying that? Why are we saying that, Chen?
Why are we saying what?
Why are we saying this angle is equal to this angle here?
Because they're corresponding.
Yeah, because we have corresponding angles, and then the corresponding angles are equal because we have AD, which is parallel to what to BC. Okay, we're done with that one. Now we are in the red circle. As soon as we jumped here, we got into the red circle. So now we are in the red circle. So as soon as you get an angle now, you want to check who's creating this angle that you just created. I get this is new. So you want to check, always check that, Who's creating this person here? So who's creating angle D1?
AE.
So it's AE. So we have AE who is creating what? Angle D1. Okay. Is there any other person who's created by AE? That's what we want to check.
Yes.
P7.
It's what?
P7.
P7 X plus Y again. And then what will be our reason here, Jane, as we close this one?
Angles in the same segment.
So we have angles in same seg. And then this is how we approach the question, guys. Now, let's quickly do this one. You are going to pause there and then we approach this question here. This one here.